Good evening, everyone. How are you all? I hope you are doing great. I can see that most of you are preparing for GATE and ESE examinations. And here today we will be seeing the importance of this subject and how to prepare for both this GATE as well as ESE. Now here, moving ahead, let me consider the weightage that we have for GATE as well as for ESE. So mostly considering GATE, for GATE I can say that so we may get questions for 4 to 6 marks from machine design. So I can say that 4 to 6 marks, a bit in the combination of machine design and strength of materials. Exclusively speaking, so we may get questions for at least for 4 marks. Okay. So in here, don't ask me, sir, do we have any guarantee? So that we may get for sure for 4 marks. See here in GATE examination, there is no guarantee that we can say. So we cannot predict that, we cannot say that only for these many marks we get questions from this particular subject. So here we are simply analyzing, here we are simply estimating. So we are assuming that for these many marks questions may come. So by considering the previous estimate, by considering the history of GATE, that is exclusively in mechanical, we can say that. So at least we can get for 4 to 6 marks from this subject. Sometimes it may even go beyond this as well. Okay, this year I'm expecting even questions for more than 6 marks. Why? Because in the past that we have seen, from subjects like mechanics, heat transfer and other subjects, yes, they have asked for many marks. So that's the reason why even here, this year, I'm expecting, so we can expect that this year it's time for machine design. Why? Because most of them are not completely neglecting this subject. For that reason, I can say that, yes, this year it's going to be the time for machine design. Okay, so anyway, so I wish you all the best for your GATE preparation. So I wish you'll be getting at least 4 marks from this subject. And one more thing here is that, so for ESE, if I speak of, for ESE, for sure, again speaking of history, I can say that for the past 4 or 5 years, if you have seen, so we are getting at least 10 questions, 10 to 15 questions from exclusively from machine design. 10 to 15 questions. Can you imagine the weightage of this subject even in ESE? So we have good weightage for this subject. So please don't neglect this subject during your preparation. Now here, how do we need to prepare? So here, considering the syllabus, as this is the syllabus that we have, where we focus on static loading, fluctuating shafts, brakes, clutches, bearings, joints, and spur gear design and springs. As this is our, as this is the broad classification of the syllabus that we have, majority, I can say that majority of the questions are generally asked from these chapters. Okay, so here from static and fluctuating loading and shafts, you can see that. See here, shaft is, again the category of static loading, and we always design shafts here in static loading and fluctuating loading. And remember that, so these 3 topics possess very huge weightage. Now here, the second weightage goes to joints. I can say that even joints has huge weightage in GATE examination. And here, if that is ESE, and we can see good number of questions from fluctuating loading. So here, this is the first, I can say that the probability of getting questions from this 3 topic, that is 1, 2, 3, 4 topics, is at least 60%. So we have 60% probability of getting questions from these chapters. And here I can say that from brakes and clutches, so we at least have, I can say that 20% chances are there that we can get questions from this chapter. And here, from bearings, we can expect for 10%. And here we can see that from spur gear design, I can say that at least, from the past history, I can say that at least for 7 to 8% we can get questions from this topic. So let me consider that as 7%. And here, so the least chance is for springs. So this is the percentage by on the basis of percentage. This is the level that we can see. See here we can consider if at all if you want to get good marks in GATE examination. Let me assume that if at all if for 6 marks questions were asked. So here at least for 4 marks the questions will be there from static loading, fluctuating loading and joints. Okay, you need to understand this simple point. Okay. Now here, how to prepare these chapters. So here, what are the types of questions that are expected and how do we need to prepare the questions from these individual chapters? Let's see here. Now here, primarily I'll be focusing on static loading, fluctuating loading and joints. Why? Because these chapters completely revolve around a particular condition. What is that condition? Let's see here in detail. Now here, from the first chapter, that is from static loading, I can say that this is from first chapter. There are various categories of questions that are expected. Let's see what are the types of questions that are generally expected from this chapter. Now here, we know the equation for, generally we know, so in case of static loading, the loading which was applied, the static loading was applied gradually. As this is the concept that we have known, and there are 3 different stages of gradual deformation, elastic, plastic and fracture. And here for the component to be safe, remember that the component has to be only loaded within the elastic region. Now here on this basis, so here we can expect that these kind of questions are generally expected from this chapter. So we know that whatever may be the applied load, okay, so this has to be lesser than or equal to strength divided by factor of safety. Now here, let's see what are the types of questions that are expected. Okay, sometimes he'll give dimensions. Let me assume that. So for given dimensions, he may be asking us to identify. So I'm going with first category of questions. He'll give dimensions, which means area is given. And here, the strength of material will be given. Let me assume that that is either SYT or SUT. And he'll be asking you to identify what is the strength. Okay, which means here, if that is axial loading, remember that we need to identify tensile strength. Which means the first category of questions focuses on strength. The first category of question focuses on strength. What is the strength under axial loading? That can be under shear loading, bending or twisting. He may be asking us to find the value of strength. Okay, this is the first category of question. And here, what is the next category? So here, he'll be asking us to identify what is the maximum possible load that can be applied. So what is that? He may ask us to identify what is the maximum possible load that can be applied on this member. Now, using this simple relation, I can easily estimate what is a applied load. And here, for a given applied loading, see, when he'll be asking us to find applied loading, so in the next category, so here he'll simply give the stresses, whatever the stresses that we have, and he'll be asking us to identify what is the maximum possible load. Or let me assume that he'll give axial load. So axial load will be given, and here he'll say that bending load can also be applied. Bending load can also be applied, and here he'll give the material properties SYT, and he'll also give factor of safety. Now here the magnitude of one particular strength will be given, and he'll be asking us to identify what is the maximum possible other load that can be applied. So this is the other type of question that can be asked. And here the third category of question focuses on factor of safety. Remember that only these are the categories that we have here in static loading condition. If at all, if you see all the questions, all these questions are revolving only around these 3 particular questions. Now, you need to understand. See here, I'm going to give you the best way of understanding here. Remember that. First, you need to read the question carefully. Read the question carefully and then try to keep these in the form of, let me assume that he says that the component is subjected to axial loading. He'll not represent the diagram corresponding to that. Okay, now here as he says that it is axial loading, now immediately you need to visualize. Okay, as this is axial loading, now the component, so in this component every particle is critical. Now you need to immediately visualize that. Okay, now here visualization while reading the question plays a prominent role. Okay, now here we call this as, generally we call this as pre-thinking. So what is actually pre-thinking? Now here reading the question and understanding that and analyzing what he is asking is what is generally considered as pre-thinking. Now here as he gave certain statement, now you need to visualize the statement. Okay, this is point number 1. Now here, let me assume that he gave certain magnitudes of principal stresses, sigma 1, sigma 2, sigma 3. Okay, now you need to understand that, okay, there is a particle, over this particle, there are 3 different principal stresses whose magnitudes are of this particular values. Okay, now here, once you read the statement and once you visualize the statement, remember that you need to get to the particle. Now you need to first identify what is the critical particle. In any situation, first identify the critical particle. What is a critical particle? It is considered to be the most heavily loaded particle. Now locate its location and then find the magnitude of stresses on that critical particle. So here what is the first point? Locate or identify critical particle okay. Now here first if you locate or identify this critical particle, then the second procedure, the second point is to now here find the magnitude of stresses. Okay, find stresses on critical particle. Now, this is the condition. So here, first you'll identify the critical particle, then you'll find the stresses on this critical one. Okay, so let me assume that he'll give the loading to be axial loading. In case of axial loading, every point in the component is critical. If that is bending, if that is pure bending, I can say that extreme particles from axis of rotation are critical. If that is pure twisting, all the surface particles are critical. Likewise, he may give us the combination of loading. Now, under this combination of loading, we need to identify what? The critical particle. And then as he gives multiple loads or a single load, now corresponding to that, identify what is the magnitude of stress on that particle. Okay, at that particular point. So particle in the sense, it is a point where the load is becoming maximum in the component. Now, once you identify these stresses, then the next point is what? The next is find the relation. Okay, find the safe condition. Okay. Now, what is the third point that you need to do? You need to find the safe condition. What is the meaning of this? Suppose he is asking us to consider axial loading. Now, we know that under axial loading, the maximum load that can be applied is what is tensile strength. Now, I can say that here, in this case, the applied load has to be lesser than or equal to its tensile strength is the safe condition. This is considered to be the safe condition. Now, you need to frame such safe conditions, or let me assume that he is asking us to consider Rankine theory. According to Rankine theory, what is the condition? Sigma maximum, the safe condition according to Rankine, is the maximum possible stress, maximum principal stress has to be lesser than or equal to SYT. If at all, if you want to introduce factor of safety, you can introduce factor of safety on the right hand side. Now, this is the relation that we have. Or if at all, if that is von Mises theory, remember that the equation has to be sigma 1 minus has to be lesser than or equal to SYT by factor of safety. If that is shear stress theory, what is that equation? Tau max. See here, from from situation to situation, these conditions are changing. Now you need to identify, so which particular theory is given or which particular loading is given and what is the safe condition according to the information given. Now this is what you need to estimate in the third point. Okay, and fourth point, substitute the values and find your answer. So here, so in the last step you will get your answer. If at all, if you follow these four procedures, 4 steps, I can guarantee that you will be able to solve any question from this chapter. Any question can be solved from this chapter. This is guaranteed. Mark my words. Now here, please, it's my suggestion. It's my suggestion. That's it. Either you want to follow or not, that's your choice. But try to incorporate this procedure in your preparation. Okay? Now, moving ahead. This is from first chapter. Now in first chapter, please say me what kind of loading was that? That is gradual loading. That's the reason why whatever the gradual load that is applied, that remains constant with respect to time. Okay. Whereas in the second chapter, so what kind of questions are generally asked? Now here, please do follow this procedure in first chapter. Now here, what about in second chapter? In second chapter, we need to identify what is the loading given. Again, the same thing. See, in the previous chapter, we have identified the critical particle. But here it is not the case. Now here, in this case, there is no necessity of finding critical particle, or sometimes, so he may give us some loading condition. Let me assume that. So here, this is the shaft given. Now in this case, in this stepped shaft, he is asking us to identify certain, he'll be asking us to identify what is the maximum load that can be applied on this member, or maximum bending moment that can be applied on this member. In such situation, please say me which section do we need to consider? Now here again, in this case, the critical section has to be considered. In second chapter, as we know that, so there is significance of stress concentration, so we need to consider the critical section. Now, if I consider this to be the critical section at this location, I need to find my parameters. Okay. Now, what are the various types of loads that we have? We need to understand that. Fluctuating loading is nothing but the sinusoidal loading. Okay. Remember that it is a sinusoidal form of loading. So here, if you see, so here the loading will be wavy in nature. Now here, these kind of loads are generally represented as P is equal to, we know that, these are represented as PA sine some function of time plus mean. So we know that this can also be written as A sine BT, this is one particular equation, plus C. Now here I am writing this to be the equation of fluctuating loading. Remember that, so there is some constant component of load where load is not going to change with respect to time. Now we are calling that as static load, and that static load is represented by mean load. Remember that fluctuating load is the combination of both the cyclic loading. Now this is representing this particular cyclic variation, and this is representing the constant component. Okay, about what position it is trying to vary. Now, if at all, if you can understand that this fluctuating is a combination of cyclic as well as static, then your problem is over. Now, you can easily tackle questions from this chapter. Now, here, he'll be asking, so he'll say that the shaft is subjected to rotation and it is subjected to lateral load. Now, in such situation, you can see that as the shaft is subjected to lateral loading, we may think that the shaft has to be designed. So, you will forget the term rotating. Now here, when you forget the term rotating, what will happen? You will try considering, you will go with the design under static loading. You will assume that this was loaded gradually, and then you will go to first chapter and then you will design this member. It is not the case. First, you need to understand what is the loading which is given. Now, whatever is the procedure that is given here, locating the, locate or identify the critical particle. First, please say me, even in second chapter, how can we do that? First, if you know what kind of load is given, Now here in second chapter, what are the various types of questions that are asked? Now in second chapter, he may ask us a question on reversed loading, or under reverse loading, again two subcategories, either for finite life or for infinite life. Okay, and the next type of question is asked on fluctuating loading. Okay, if you see here, that is any question, first we need to estimate some points here. Observe here. Now here, if that is reversed loading, okay, so he'll say that what is the amplitude stress corresponding, or find the endurance strength of the member. For reverse loading, see whatever the fatigue test that we consider, this fatigue test, which is nothing but R.R. Moore's test, remember that. So in this loading condition, we are assuming that the loading to be reversed bending, which means cyclically that is changing, that is cyclic loading, remember that. So the experimentally found out loading is, experimentally considered loading is cyclic loading, and reverse loading is cyclic loading, and we have identified certain charts. Remember here, for infinite life, the condition has to be what? So for infinite life, the amplitude stress has to be lesser than or equal to SE. Now what is SE here? It is considered as corrected endurance strength. It is not endurance strength. It is not an ideal value. It is the real value. Okay. It can change from component to component, and from situation to situation also it can change. Okay. Now here, so depending on the situation, you need to write this equation. Suppose, so as I said, read the question, and then, so here in this case, finding the stresses on critical particle, right? Now here in this chapter, first we need to identify loading. What is the loading that is given? First you need to identify that. Once you identify loading, so here either that is fluctuating loading or that is reverse loading. First you need to identify that, and then the second one is find stresses, amplitude stress and mean stress. We know that for a given amplitude, for a given reversed loading, there is no mean stress, there is only amplitude stress, and find all the values of amplitude stress which is given, and here find amplitude and mean and group the data. Suppose, see here, whatever may be the given loading condition, first we need to see that what is the value of amplitude and mean. See, for a reverse loading, I can say that there is no value of mean. Okay, there is only amplitude. Now, in such situation, what we need to do, there are two types of questions asked. Now, he'll be asking us either to identify what is factor of safety, or he may ask us to identify what is the life of member. Now, here, if at all, so here, considering reverse loading, there are two cases. The first case is infinite life. Under infinite life, what is the condition? Whatever may be the amplitude stress that is given, this amplitude stress has to be lesser than or equal to SE divided by factor of safety. Now here in the other case, for finite life, what is the type of question that can be asked? Under finite life, he may ask us to identify any one of these parameters. For a given value of stress, he may ask us to find the value of N. Or for a given value of N, he may ask us to find the value of S. So here such is the question that is expected. Now here, once you group this data and then identify which equation to be used, then you will get your answer. Now find the unknown. Now here, that can be any loading condition. See here, okay, the third point here is, okay, this is fourth point. The third point is find the safe condition, or I can say that find the condition. We need to find the condition here. And the last point is finding the unknown. Now if you observe carefully, So here for infinite life, what is the condition? This is the condition. For finite life, this is the condition. If at all, if that is fluctuating loading, we'll be having the conditions from Soderberg theory as well as Goodman theory, modified Goodman theory. There are few other theories. Okay, so we'll get the, we need to extract the condition then, and then finally find the unknown. This is generally the procedure that we need to incorporate. Okay, now similarly, if I proceed further even in the other chapters, so this is how you need to extract these steps. What are the steps to be followed in every chapter that you need to write? That is your choice. Now here, what you need to do, what is your task? Okay, in first chapter, what are the types of questions that are asked? Now you need to make an algorithm now. Okay, if at all, if any question is asked, I need to follow this flow chart. If at all, if I follow this flow chart, okay, I'll be able to get the answer very easily. Now I have given the flow chart for first chapter as well as second chapter. Now what you need to do, you need to make certain flow chart for the other chapters also. Okay, so here in one chapter, one type of question is asked. If that is brakes, what is the type of question that is asked? So let me consider brakes. So let me consider brake. So if that is brakes topic, remember that he may ask us to find the value of torque capacity. Now here, what is the kind of question that he'll be asking? Finding torque capacity is the question, or finding the normal reaction is the question. Now here, how to solve the question if that is shoe brake or block brake? Remember that anything here, remember that only one type of question that is asked, either torque capacity or normal reaction. Among these two, only one possibility is there. Majority only among these two, the task is present. Now here, how to solve a question? So what is the algorithm here that we need to follow in case of brakes? So in case of brakes, if at all, if I consider the brake to be a block brake, first, what is the point that you need to identify? So first, we need to find whether it is self-energizing or non-self-energizing. See, you need to first estimate whether it is self-energizing or non-self-energizing. If that is self-energizing, so second one is find normal reaction N. See here, once you can identify whether that is self-energizing or non-self-energizing, you can easily write the equation for normal reaction. What is that? So we know that it is PL by A minus or plus mu B. Minus is for self-energizing, plus is for non-self-energizing. Now here, so here first step is what? Find this particular, whether it is self-energizing or not. And the second one is find what is the equation for normal reaction. Either it is PL by A minus mu B or A plus mu B. Corresponding to self-energizing minus, corresponding to non-self-energizing, it has to be plus. So this is what is the thought that you need to get to your mind. And then once you write this equation, then the third step is what? Finding the unknown, which is torque capacity, find torque lost. Now here, this is the step that has to be followed. Now if you are not, see, these are the majority of questions which were asked previously. Remember that in every chapter you need to create certain flow. Now here, even in examination, if you know, so if you write this flow in examination, obviously, as you know that this is the flow, obviously your mind says that yes, follow this particular flow, and then you'll get your answer. See, once you write, then you try solving questions, then you'll see the difference. Now it is my suggestion according to, so that is your choice, either you follow or you don't follow, it's up to you. Now remember that writing this flowchart is going to reduce lot of time during calculation or during solving. Okay. Now let me assume that you have made this procedure, you have finally made this procedure and then you started solving questions. Then what do you need to do? Once you start creating this flowchart and then once you start following this procedure, then there are two different types of things can happen. Okay, while you are solving problems, the first thing is you may take time to solve these questions. You may take time to solve these questions. If at all, if you are taking time, again there are two possibilities. One possibility is finally you may get a correct answer, or you may get an incorrect answer. So here, if at all if you are getting an incorrect answer even after spending more time, which means you are not conceptually clear, which means you need to revise that topic. So mark that. Okay, so what you do, so try to create, let me assume that, so in the chapter machine design, whatever in the subject machine design, so try to allocate, so certain page to all the chapters, all the topics individually. Try to write all the contents that we have. So that can be, let me assume that first chapter is divided into Rankine's theory or fundamentals. First fundamentals, okay, Rankine's theory, and then Tresca theory, and then von Mises theory, or uniaxial loading. Likewise, you need to create all the list of concepts that we have. Okay, so whenever you see a question, so that you are taking time and then you are marking it as incorrect, try to mark a point just beside that. Try to mark a point just beside that. So here this mark indicates that, so here let me assume that in the first question you have made it incorrect. Now here even in the second question you have made it incorrect, give one more point. Now here even in the third question you have made it incorrect, give one more point. If at all if you are making incorrect even in the fourth step, likewise try to add as many points as you can. If at all if you are going with many incorrect answers, okay. So let me assume that you have made it incorrect, so you have given a point. Let me assume that you have made it correct, but the procedure that you have followed is not correct, but by chance, by some chance, you have made this, you have got the right answer. Out of luck, I can say that you have got some luck factor. Because of this luck factor, you have got this question right. If at all if you are getting this answer right because of your luck, try to add one more point just beside it, which means you need to make this concept clear again. Okay, which means more number of points over there, so suggests that you require more conceptual clarity from that particular concept. Okay, less number of points or no points suggests that, so here you don't require much conceptual clarity regarding that particular concept. Okay, so this is my suggestion. So here, so try to incorporate this particular method. Let me assume that you have taken more amount of time, so that in one situation you may get a correct answer or incorrect answer, or if that is correct, again I can say that out of luck you may get the answer to be correct, or so by conceptual clarity again you have made it as correct. Okay, even though you have made it as correct, remember that you need to mark a point here. Why? Because you have taken more time, which means you require further more conceptual clarity regarding this. Either it is correct or incorrect, you need to mark a point here. Okay, now let me assume that the second way, the second point that you need to note here. Now here we need to understand that, okay, you have made it correct, the question that you have made is correct, but that too in very short span of time. See, this is taking very large time, T is large here, and here this is time is very small. You have taken very little time to solve. See here, let me assume that you have taken very little time to solve this. See here, there are two chances again. Out of luck, you might have got this answer. So out of concept, you might have got this answer. If at all, if that is on the basis of concept, then there is no worry. So you don't want to worry about that particular question. If at all, if that is by luck, remember that you need to mark a point again, which means you require further more clarity. So out of luck, we never solve a question in GATE. So with concept only, we need to solve questions in GATE. Okay, and one more point to be noted. Here we are taking more time, here we are taking lesser time, and here let me assume that. So there are certain questions which you solve, generally you solve, and they go incorrect. Now incorrect. See here, you are solving them and then you are getting the right answer or incorrect answer, that is okay. Here it is more time, it is smaller time. Now here let me assume that you have solved the question in regular time period and then you are getting it as incorrect. Okay, if that is incorrect, which means again you require further more clarity regarding that. Okay, more the number of strikes that you get from a concept, remember that you require more and more conceptual clarity regarding that. Okay, now Let me assume that you have made it incorrect. Okay, if that is correct, there is no worry at all. You don't want to worry anything about it. Now, the fourth thing is that there are some unanswered questions. If there are any unanswered questions, remember that again, if your answer is, if at all, if you are unable to solve it, and if that is unanswered, remember that again you need to mark a point just beside that concept. Remember that. So here you need to review your exam, whatever the test that you are writing. See, just by practicing you are not going to get anything. You need to write this test. See here, this is corresponding to the test that you have written. Now here, during the review, as you have written this test from a given subject or from a given chapter, remember that these are the 4 steps that you need to consider during your review. Remember, personal introspection is the best thing for correcting any mistake. Okay, if at all, if you are unable to correct your mistake, then how can you make a correct attempt in examination? See, this is highly impossible, right? For that reason, again, I am saying, remember, here for you to make any answer correct, okay, remember, during your review, that is, after writing any exam, as you are going through review, you need to follow these 4 particular steps. Okay, if at all, if you follow these 4 particular steps, and then if you mark some points just beside the concepts that you are not clear of, remember that more the number of strikes that you get, so more the conceptual clarity that you require. Less the number of strikes that you get, less conceptual, so which means you are conceptually clear in that particular concept. Okay, do understand this. So here, this is a particular strategy that you can adopt. See, the first point that you note is, you need to make certain algorithm for the solving of problems. That can be machine design or that can be any other subject. So there will be certain algorithm to solve any question. Okay, there is certain flow chart. You need to follow that flow chart so that you can get an answer very quickly. Okay, first you need to crack that flow chart and write that flow chart first, or write that algorithm somehow. Try to write that, and then when you are solving some questions or when you are trying to attempt some examination, remember that you need to keep on. So first you need to review that particular exam, and in that exam, if at all, if you are going through these 4 particular points, I can say that you can easily correct your mistakes and then you can excel in that examination. Now these are my points, so to help your preparation better. Okay, now here I wish you all the best. So here that is all from my side. I have put my words here, I have marked my words here. Now it is your duty to either follow or not follow this particular procedure. But here remember that it is scientifically proven that if at all, if you are following this, if at all, if you are reviewing by this particular method, there are chances, 90% chances that you may avoid committing mistakes. 90% chances are there that you may avoid committing mistakes. See here how much accuracy is there. See, there are very less chances that, there are very few chances, I can say, that you may not get through this particular concept. Okay, remember that. If at all, if you are going through this, there are chances, good number of chances to excel in that particular exam, or to crack that particular exam, or to crack that particular subject. Okay, so please do correct your mistake by following this particular procedure. I wish you all the best, all the very, very best. Okay, and with this, so let me end this session here. And remember that this subject is not that difficult, and don't treat this subject as a difficult one. Now here in tomorrow, day after tomorrow's session, we'll see a concept regarding from this particular subject, and then we'll see how simple this subject is. And here we can easily get, so from that can be any chapter. So here from this subject, you'll be able to get marks very easily, and you can solve questions if you follow these algorithms in less than 20 to 30 seconds. Okay, so this is guaranteed. I wish you all the best, everyone. Take care. Have a great day. Bye-bye.